Hello guys, today I am going to talk about chemical energetics and thermodynamics. In the part 1, I'll just talk the basics that for a chemistry student, why it is a need to know thermodynamics. Because engineering students as well as physics students all learn about thermodynamics. Then what is there in it in chemistry? See, for any dynamics means if you recall the Newton's law, for any movement you need energy. Then do we means the chemistry people deal with the energy, deal with the movement? Of course we deal with the movements. What is there in our subject? We deal with matter, its chemical properties and its chemical transformation, and matter's physical properties and physical transformation. This term transformation itself indicating some sort of movement. Like you have a certain matter called A. It moves to B and B maybe moves to C. Sometimes A can directly moves to C. Or in number of changes we see. This may be chemical or this may be physical. When we look at chemical changes, means chemical transformation, there what we see that a molecule A by some sort of bond breaking process and further bond making process converts to B. And if we look at the physical process, suppose the matter is same, but A is the gaseous state, B is the liquid state and C is the solid state. There also we see movement like gas to liquid, liquid to solid or vice versa. And all this movement, with all this movement, some sort of energy term always is associated, because this indeed is a movement. Now, quickly you can say that in gas, the molecules get maximum freedom to move here and there, and for that it needs energy. But whereas in liquid, the molecules movement is much restricted. From this knowledge we can say simply that the same matter in gaseous state having much more energy within it than in liquid state, and which is again having more energy than the solid state, because in solid state the molecules movement gets restricted. That means what? In solid state, within the solid there is no energy? No, this is not the case, because still those molecules will vibrate within the solid, and for vibration also some sort of energy is required. So energy term is everywhere in chemistry, so we should know how to deal with it and how matters interacts with energy. So this is the basic thing. And if we now if we consider the what kind of transformation will take place, see, the universe's normal rule is to reduce the energy content. Okay, suppose if you have some sort of some stuff in second floor, and if you simply leave that thing, it will it will come with free fall to the ground level. But ground to second floor, no matter will go freely until you are taking that matter and do some external work to push that matter to the second floor. So energy reduction, my point is energy reduction is the spontaneous process. If we take example with human life, normally we see our three states: standing state, sitting state, and sleeping state. Now it is common knowledge that in standing state we are more destabilized. We get some, after some time we may get tired. We may look for a chair to sit down. And even when we are not comfortable with sitting also, we may look for a bed to get some sleep. That means a standing man may have the ultimate goal to go to the sleeping mode. But one point you should remember: a person cannot switch it himself or herself just like that by electric switch off on process. If you are standing somewhere and if you want to sit down, you may look for a chair, and if you find a chair, you need to go there by foot and access the chair. Again, if you want to go to sleep, then you may go to the bed. You may need to go. In fact, you need to go to the bed by foot. So that means, why I am saying, because some sort of process is involved to change your state, like this working process. The point to be noted is, whenever you are standing, sitting, or sleeping, as per definition, you are not working. Although you are in destabilized mode, but you are not working. But when you are moving from one place to another, you are working. You are spending more energy. Even to go to the some sort of stabilized state, you need to spend some energy. And this spending may differ. You may work, or you may go something like this, in this way. Like by some sort of, by influence of some sort of external thing, you may run also. The very same thing is applicable for reactions. That reaction, whatever reaction may go in some sort of normal speed, inbuilt speed. If you want to accelerate the reaction rate, then you may need to have some external influence. So here the dog is the influence. So dog is acting as catalyst or energy booster. Okay. So these are the common way I am talking, that the change from changing one state to another state, the process may differ. But point is, the process needs some work done to be work done. Now come to the energy graph. Energy graph, I want you to know how to read the energy graph. In y-axis, the energy term is showing, and more the height it is having, more it showing the system has having more energy. Okay. So what are the things we saw earlier? These are the states we saw. Now if I ask you, if I throw the question to you, the which state I put in higher level in y-axis, then obviously the answer will be the working mode will be in the highest level, then the standing, followed by sitting, and lowest will be the sleeping mode. Now I am showing some sort of transformation. That's why destabilized state to stabilized state, if you move, you need to go through further unstable state, that is working mode. Sometimes, see, there are several permutation and combination we can make, but all permutation combination I cannot show in the same graph. Anyway, suppose you have your bed in the first floor and you need to go through steps. So that time you need to do more work, even working in the same layer. Still you will do that. You will walk to the first floor or second floor, whatever, through steps, and you will access the bed, and eventually you will release your internal energy to the means lowest level. The point is, from this graph itself, some other topic I am just hinting you, which is not this class's business. That is two things I want to show. That suppose net energy gain or energy loss. So A to B, the energy gap is whatever you can measure, okay, through the y axis value. So initially you need to give is some sort of energy input to come to the red color stage, and then the system will release the energy. Suppose if you think about a chemical reaction, A to B, A will not come to the B just like that. You may need to push some, I am talking about you may need to supply some sort of energy. The gap will be from the red line to this A. This much energy you may need to supply. But once it reach to the red level, once it comes to the B, then this much energy it will release. So net gain means net output of the energy will be equal to the gap between A and B. And one more thing I want to say, you may ask me, sometime I am talking this, the energy supply from A to this red line. Here you see where my arrow is shaking is less compared to the A to this line. So based on this, the molecule A may choose the path whether it will go to B or C. Suppose the molecule A doesn't get the supply of enough energy to go to the bed, but the molecule A is getting enough energy to go to B, to kickstart the process. So in those cases, normally molecule A always will be willing to go to the C, but if molecule A is not getting enough energy to reach to the bed, it cannot go to the C, although it love to go to the C. So A to C is the thermodynamically controlled reaction, and A to B is the kinetic controlled reaction. Okay, in practical example I can say, suppose you are in some sort of office or college. There, even if you are tired, you cannot access bed. Only what you can do, you can look for a chair and sit down to get some sort of relief. So based on the accessibility and the energy supply, sometimes kinetic control product happens. Always we don't get thermodynamic controlled product. Now before going to the thermodynamics, I want you to get familiar with some terms. Firstly, it is the system. What system means? System is the part of the universe contains certain quantity of matter which is separated from the universe for observation or for research. That is system. And rest of the universe called surroundings. Now the point is to separate system from the rest of the universe, you need boundary wall. Suppose in your area there are several houses are there, but imagine if all the houses don't have boundary wall, then there won't arise this kind of point that this is my house, that is your house, that kind of things will not be there. So there must have some boundary wall. Now based on the boundary wall, system can be subdivided into three parts. One is isolated system, when the boundary wall does not allow either energy or mass to get exchanged with the surrounding. That kind of system called isolated system. Second one is closed system. Here energy exchange is possible but mass exchange is not possible. And third one is open system. In this case both the energy and mass can be exchangeable with the surrounding. Now to have this three kind of system, the walls are of two types. One is diathermal wall, another one is adiabatic wall. Diathermal wall obviously permits energy to transmit, and adiabatic wall do not permit. So for to get isolated system, the wall you need is the adiabatic wall. As example, I can say that in your household you will see some dewar flask where you can keep some hot tea for a long time or some cold water, whatever. It will be remain hot or remain cold for a long time. So absolutely 100% adiabatic wall is not possible, but the funda is like this. Now come to the parameters or properties of the system. So far you got what is called system and what are the types of systems are available. Now to define a system you need some parameters or some sort of units. Like this, suppose if you want to define a human being, you measure certain things, suppose height, body weight, chest, blood pressure, sugar, etc., etc. Even eventually you may read that human being's DNA also. So these are the parameters you need to define a particular human being. So we need to define system as well, and to define a system we need some parameters. Okay. So what are the parameters? Normally we know, like composition, volume, pressure, temperature. These are the fundamental parameters. Suppose you have a mixture of material in your system, until you know the composition, then within the mixture of matter, what matter is how much you cannot get. So composition is the parameter which will define the which matter is present in how much quantity. Okay. Along with the volume, help of volume you can define. Pressure, temperature, these are the thing you need to know the energy content within the system. Other than that, these composition, volume, pressure and temperature, there are several other things, other parameters are also there, like refractive index, viscosity, dielectric constant, etc. Now you saw the parameters. Now these parameters also can be divided in two parts, extensive property or intensive property. So those properties which are dependent on the amount of mass of the system is called extensive property. Suppose you have some amount of matter, means some volume of matter. If the matter's mass increase, that volume also will increase. The surface area also will increase. Total energy content will increase. Okay. if you have 1 kg of coal, the energy you get by burning that coal obviously will be 5 times less than 5 kg of coal's burning energy. So energy also extensive property. An intensive property like temperature, pressure, density, refractive index, etc. are intensive property. These are all independent of mass of the system. Okay. Suppose you have 1 liter of water. From there you bring out 10 ml of water, and both the remaining water and 10 ml water, if you take the temperature will come same for both the setup. That means temperature is not dependent on the total mass of water. So this way other things. Now come to the state of the system. What happens? That system can change its state. Like if you are a system, your standing mode is one state, your sitting mode is one state, your sleeping mode is another state, in the same way. Now in chemistry, the states can be defined by only by the thermodynamic parameters. Suppose you have gaseous systems in 2-cylinder gas. In 1 cylinder you have 200 atmosphere pressure and 150 degrees centigrade temperature, and in another cylinder you have gas with 100 atmosphere pressure and 50 degrees centigrade temperature. That means both are gaseous, but these two are not the same because pressure and temperature value are different. So these parameters define the state of the system, in which state the system is present. Now, as I said earlier, that from standing mode to sleeping mode or standing mode to sitting mode, you need to go through working process to go to a new state, one state to another state. So in chemistry, from one state to another state, when system moves, there are also some process get involved to change one state to another state, and this is sort of movement, right? So all process to run need some sort of energy. Okay. Now the point is, process can define in two ways: isothermal process and adiabatic process. In isothermal process, whatever energy you need to run the process is externally supplied. You need not to the system need not to utilize any internal energy. Okay. That's why temperature will remain constant. In adiabatic process, since you are to run the process, you are not getting any external energy, so the system need to utilize its own internal energy to run the process, and for this the internal energy from will reduce. The system's internal energy, suppose the state A to state B, it is moving by adiabatic process, so the state B will have less internal energy than state A, because state A already will utilize some amount of internal energy to run the adiabatic process. If you try to look at real life example like this man is walking 100 miles. Sorry, that is too much. 10 miles, and food is supplied to him. He is taking whatever food is necessary to walk 10 miles. Then what will happen? This man's body weight will not get reduced. This man's body weight will remain constant. But in case the man is moving 10 miles from point A to point B and no food is supplied, then this man will burn its own fat for that movement. That means this man is utilizing its internal energy, whatever stored within it, to get the process done. Here the process is 10-mile walking. You got the point? Now, state sometimes is in equilibrium. Equilibrium means kind of, it is dynamic equilibrium. Means it will look like the state is not moving, the state is fixed, it is not moving, but in reality state is moving A to B. But the point happened, the amount of movement A to B is equal to the amount of movement from B to A, and for an outsider it will look like there is no movement. Okay, that means suppose there are 10 people sitting in point A and 10 people sitting in point B, 5 people sitting in point B, and at any moment 5 people's moving from point A to point B, and same time 5 people are moving from point B to point A, then in any moment of time you will always find that 5 people are sitting at B and 10 people are sitting at A. So this way it happens. So there are 3 conditions they are given, you just go through. Okay, first its composition will remain fixed, as I said. Temperature of all part of the system will be same, means the energy equilibrium also will reach. And thirdly, the force unbalance won't be there. Okay, so this is the state of equilibrium, and in next part I'll move to the heat, work, energy, this kind of terms. Means I'll start the basic thermodynamics in the next part. Okay, so please subscribe and comment, give your comment and likes, so that I get encouragement for the future videos. Thank you.